In our new unit, Unit 12, we're going to be looking at angles and properties of shapes. And what we're going to be looking at in this unit is we're going to learn about something called turns and how they link with this idea of angles, which we can then move on to start naming some of these angles. So we've got the idea of a right angle. And in order to create these angles, we're going to learn about lines, and we're going to be understanding and drawing parallel and perpendicular lines and vertical and horizontal lines. And then we're going to be able to apply all those facts that we've now learned about turns and angles and lines, and we're going to apply those to our knowledge of 2D and 3D shapes to help us describe them, recognize them, and actually make them ourselves. In this lesson, we're going to be trying to answer the question of what is an angle, and we're going to use the idea of turns and quarter turns and half turns to allow us to start to understand how they relate to these angles. And we're going to start by looking in our textbook and heading to the NASA headquarters, where we can see a video image of Rover on the moon. And we're going to have to give Rover some instructions on how to turn around so he can take pictures of his lunar landscape. So for question 1A, we're asked, the scientists want to photograph the center. What instructions should they send to the rover to turn it to face this crater? So the first thing we're going to be thinking about here is, where is the rover actually facing? Look at the arrow that's pointing and see whether you can identify what the rover is facing already. And then, looking to the side, we can see there's some buttons. What do you think these buttons will actually make rover do? And now, imagine you are rover. Which way would you turn first? And how would you use the buttons on the right to help you do that? So for question 1A, the scientists want to photograph the crater. What instructions should they send to the rover to turn it to face this crater? And then for question 1B, how would the rover make a complete turn? So again, think about where rover is pointing to and think about what a complete turn would be. Where would he be pointing if he made that complete turn? So now we're ready to give those two questions a go. So question 1A, the scientists want to photograph the crater. What instructions should they send to the rover to turn it to face the crater? And question 1B, how would the rover make a complete turn? Now it's time to pause the video, give them both a go, and then come and join me when you're ready to talk about the strategies we've been using. So let's start by looking at question 1A. The scientists want to photograph the crater. What instructions should they send to the rover to turn it to face this crater? So firstly, let's look at the information we're given. Where is the rover pointing already? Well, we can see the arrows pointing up, it's pointing north, it's pointing to the mountain. So we've got to take the rover from pointing to the mountain to pointing to that crater. How are we going to do that? Well, we can see that the buttons that we're provided with, they're turning left and right. They're turning anti-clockwise left and clockwise right. Think about the way that the minute, hour and second hand turn on an analog clock. If it's following that way, it's clockwise. If it's going the other way, it's anti-clockwise, the anti meaning opposite. And these aren't turning a full circle, they're turning a quarter of a circle. As we can see by the divisions marked up, we've broken our circles into quarters. So now we can use that knowledge of quarter turns clockwise and quarter turns anti-clockwise to help make the rover point in the direction we've wanted. So we begin with the rover pointing to the mountain in the north, straight up, and we're going to use our first quarter turn. In this case, I'm going to use my clockwise quarter turn. And when I press that clockwise quarter turn, the rover goes from pointing at the mountain to pointing at a volcano. But I still need to move him further because I need him to point at the crater. So I'm going to press that quarter turn once again. And when I press that quarter turn once again, quarter turn clockwise, we're pointing down towards the south, we're pointing towards the crater. So from the mountain, quarter clockwise to go to the volcano, and quarter clockwise to go to the crater. What would happen if I pressed the anti-clockwise, if I went the opposite way? Let's see. Again, we can see our rover's pointing north at the mountain, and we need to turn him to go to the crater. This time I said I wanted to turn anti-clockwise, so I'm going towards the left, or the opposite way round that the hands on an analog clock will turn. And one quarter turn anti-clockwise goes from the mountain in the north to the canyon in the west. but I still need to move further because I need to be pointing at the crater. And with another quarter turn anti-clockwise, now I'm pointing south towards that crater. So I've been able to turn 1/4 turn from the mountain to the canyon, 1/4 turn from the canyon to the crater. So to go from the mountain to the crater, I've gone 2/4 turns clockwise or 2/4 turns anti-clockwise. And remembering my work on equivalent fractions, we can say that 2/4 turns will equal a half turn. So I can turn a half turn clockwise from the mountain to get to the crater, or I can turn a half turn anti-clockwise to get from the mountain to the crater. So two different alternatives that I can use. So let's move on to question 1b. How would the rover make a complete turn? So we're looking at a mountain, and this time what we've got to think about is, what is a complete turn? Well, if I turn round a full turn, then it means I'm going to be pointing in exactly the same direction at the end. So I'm going to turn a full circle in this case. So we started with the rover pointing at the mountain, and we can see how we can turn now. So if I turn 1/4 clockwise, I point to a volcano. A 2/4 clockwise to get to the crater, a 3/4 clockwise to get to the canyon, and finally a 4/4 clockwise to get to the mountain. So turning clockwise, it was 4/4 turns, a full circle, to get a complete turn. Now let's see whether we get the same answer if we turned anti-clockwise, the opposite way. Well, 1/4 anti-clockwise goes to the canyon, a 2/4 anti-clockwise to the crater, a 3/4 anti-clockwise to a volcano, and a 4/4 anti-clockwise to the mountain. So 4/4 to go from the mountain, a full circle, and back to the mountain. So now we've seen that it takes 4/4 turns to make a complete turn. Whether that's anti-clockwise or clockwise, it makes the same thing. Now, this reminds me of the work we've done in fractions, especially adding fractions. So if we think about the idea of to make that half turn to go from mountain to crater, 1/4 plus 1/4 gave me 2/4. And to make that full turn, that complete turn, from the mountain to the mountain, again, 1/4, add 1/4, add 1/4, add 1/4, gave me 1 whole. So can we apply that as we're moving on with the rest of our lesson? Now, before I send you off to complete those questions that we've got to do in our textbook, let's have a look at a couple of questions just to get our brains really making certain we know about this. So let's have a little try this question. And you can see these are the compass points. So we started looking at them with our rover question, and we can see that we've got N for north, E for east, S for south, W for west, and those NE, NW, SE, SW, that's when you combine those two cardinal points. So NE means northeast, SE means southeast, SW southwest, and NW northwest. So think about whereabouts you live in the country. Which compass points would you say you were living in if you took the middle of the country being the center? But for this question, if the arrow moves 1/4 turn to the right, thinking whether that's going to be clockwise or anti-clockwise, which direction will it be pointing? We can see that it's pointing at the west at the moment, and you're asked if the arrow moves 1/4 turn to the right, which direction will it be pointing? Will it be A, north, N, B, southwest, SW, C, south, S, or D, northwest, NW? So if the arrow moves 1/4 turn to the right, which direction will it be pointing? Will it be A, B, C, or D? Make your choice, and then we'll see what the answer is in a few moments. So let's see what our answer is. If the arrow moves 1/4 turn to the right, which direction will it be pointing? If it's turning right, then we know that it's moving clockwise. It's moving the same direction as the hour hand. And let's see where that red arrow pointing west will go if it's 1/4 of a full turn. And we can see that the answer would be A, because it's pointing to the N, it's pointing to the north. So now we're getting the grasp of these quarter turns, and we're starting to understand how things can turn round at these angles using this idea of our turns. And Now it's time to continue with that work with the textbook so we can see our first think together question. The rover this time is facing the crater and it takes a quarter turn. Where could it be facing? Now, firstly on this one think, have you been told whether it's clockwise or anti-clockwise? Have you been told how much of a turn it's making? So where could it be facing if you ticked off those different criteria? So start on this first think together, work through those textbooks as normal, and then when you're ready, the independent work in the workbook awaits. Good luck with this, and I look forward to seeing how you're getting on so we can start applying this to that more mathematical language of what an angle is in our next session. Good luck.